Okay, for section 8.1, day 2, we are solving by using a process called Gauss, I like to say Jordan or Gauss-Jordan elimination. And as you saw in class, it's virtually the same thing as doing Gaussian elimination with a couple extra steps on it depending on the size of your matrix. So we'll solve the 3 by 3, and then like you had in the homework for day 1, we'll solve a 4 by 4 as well. Alright, so how do I solve using Gauss-Jordan? Well, you're going to start by doing the same thing you normally would by solving using the Gaussian elimination. I'm going to change this to an augmented matrix. They did us a favor by making one of the equations a 1. So usually I tell you when you're doing your homework, when you're copying it down, don't copy the actual problem and then do the augmented matrix. Just go right to the augmented matrix. So I've got 1, 0, negative 3, my row of dots, and then negative 2. Since we're going to kind of do our first step right away, just so I can not have to show as much work, I know I want to multiply this by negative 3 and add it to this one. So I'm going to say negative 3 times row 1 plus row 2. And that'll give me negative 3 plus 3 or 0. That'll give me 0 plus 1 or 1. That's convenient because I would want a 1 there anyway. That would give me 9 minus 2 or 7. And then doing the last one looks like it's 6 plus 5 or 11. And then to get rid of this 2, I would multiply by negative 2. So negative 2 times row 1 plus row 3. And that'll give me a 0 here that I want. 0 plus 2 or 2. It's going to give me 6 plus 1 or 7. And 4 plus 4 or 8. And so there's kind of doing a couple things. Changing this into an augmented matrix, although we didn't actually do it. And then showing the step for the first step. Kind of combines a couple things just to save us on the homework. Alright, on the test if you did that, that would be fine because basically this is the augmented matrix other than it has the variables in it, so that would be fine. Alright, so just remember your goals here. Got a 1 in front, got rid of these 2. I already have a 1 in front, luckily. Now let's get rid of that 2 using this 1. So next step, copy down the first row. Copy down the second row. And now ask yourself, how do I get rid of that 2? Well, I'd have to multiply the second row by negative 2. And then add it to the third row. And so that'll keep this as 0. Negative 2 plus 2 gives me 0. Of course, that's why I picked negative 2 in the first place. Negative 14 plus 7, or negative 7. And then negative 22 plus 8 should end up giving me negative 14. And you can quickly see that if you divide both by negative 7, it's going to give you a 1 and a 2. And if you don't want, realistically what you're supposed to do is do this. You're supposed to write a whole other matrix out, which is, I guess it's not really necessary when you can see what the answer is going to be. Here's what all I would want you to do. I'm not going to do it because I'm doing this in pen. But if you're doing this in pencil, if you see that if I divide by negative 7, it would give me the 1 that I'm looking for, just come over here and say I'm going to divide by negative 7 and then change this to a 1 and to a 2 or whatever the number would be. That'll save you from having to do this extra step. Since I'm doing it in pen, it would get a little bit messy, so I'm not going to do that. But that's the same thing that we did when we were solving the Gaussian. Once you got there, we just said, okay, eliminate that, put a line through it if you want to, put 1, 2. Alright, so I didn't do that, but that's what you could do. Alright, what the Jordan says, if you remember in class, once I've got the 1s on the main diagonal and these are 0s, I'm now going to use this one to get rid of those 2 numbers. So now it's like working backwards. Now it's the bottom row that you copy down, and that row will not change anymore. And think to yourself, what do I do to this 1 to get rid of that 7? Well, I'd have to multiply by negative 7. Because these are 0s, it won't change those 2 numbers, which is why these have to be 0s before you start going backwards. So negative 7 and 7, of course, gives me 0. That would be negative 14 and 11, so negative 3, and I guess I should write down what I'm doing here. It's negative 7 times row 3 plus row 2. Alright, and then I'm going to move up here. I need to get rid of that negative 3, so I'm going to multiply the bottom row by a positive 3, add it to the top row. So again, because these are 0s, the top 2 numbers won't change. Think about it, it's 0 plus 1, 0 plus 0, and now I'm multiplying by 3, so it's 3 plus negative 3, or 0. 6 minus 2, or 4. Now we are actually done. I used the 1, got rid of those 2 numbers. The next thing I should be doing is using this one to get rid of that number. We got lucky. It ended up turning out to be a 0 anyway. A lot of times that wouldn't be the case. And now that's the Jordan part. Here's the Gaussian elimination getting to getting to that point right here, or I guess you could say this point right here, where this is 1's in the main diagonals and then the 0's, the Jordan is getting rid of these 3 numbers, working backwards, which if it's a 3x3 system, you have to do 1 step to get rid of these 2, a 2nd step to get rid of those 2, so it adds 2 steps onto your work. And then there are your answers, 4, 3, 4, -3, and 2. Alright, so 4x4. Same principle, just more steps because of all the variables you have in here. And again, I'm going to try to do as little steps as I can because I don't want to have to write all this out. So I'm just going to assume that this is the augmented matrix. I'm going to copy down the first equation because luckily they gave me one with a 1. If they didn't, I would rearrange the order or do whatever it was I needed to so that I could get the 1 in front. Alright, there's my first equation. And now using that equation, I'm going to get rid of these things. So I'm going to multiply that first equation by -3, add it to row 2 to get rid of this 3x. So it's going to be -3, +3, or 0. That's going to be -6, +6, or 0. -6, +5, or -1. -12, +12, 0. -33, 30, -3. Now a lot of us are so happy that when we see this, like, oh right, I already know what z is. That's great. But you have to continue to solve using the Gauss-Jordan or Gauss-Jordan elimination. So don't get caught up on the fact that you know what this is. Still go through the process of getting these to be zeros, getting a 1 in front of this position, and so on. That's great that that happened. Think about it. What would be smart if in my next step I move that to the next row? Because that's where I would want there to be a 1 anyway. So that's what I'll end up doing. Alright, to get rid of this one, I'm going to multiply the top one by -1. Add it to the third row, or you can subtract if you feel like doing that. I just don't like doing that because of the double negatives, but obviously it's fine. So -1, 1 gives me 0. -2, 3 gives me 1. Again, convenient, because now if I switch these two equations around, I'll have a 1 in that position, I'll have a 1 in that position. That's exactly what I wanted anyway. Alright. Where are we at here? Okay, that would be -2, -3, or -5. Looks like this is going to give me -4 plus 2, or -2. And then -11 plus -5, so -16. And now I'll multiply row 1 by -6, add it to row 4 to get rid of this 6x, so -6, +6 gives me 0. -12, -1, -13. -12, -1, -13 again. -24 plus 1, so -23. And then -66 minus 9, or -75. So if it wasn't for that last row, our numbers were looking actually kind of nice. So we've accomplished kind of step number 1. I've got the 1 in front, and I got rid of those. Next step, get a 1 in front of one of those. Well, I already got it. So I'm just going to rearrange the order. So if you notice things like that, obviously that's helpful. If you don't, and most times probably won't happen, that's fine. Just continue to solve using the same process. So I'm now going to put this row here, 0, 1, -5, -2, -16. If this was a -1, I'd multiply them also by -1, just so that I can get the +1 I want. I got lucky, really lucky, that there's 2 zeros here. Just because this is a 1, if there would have been a 4 here, wouldn't have mattered. I would need to get rid of that 4 before I worry about that 1. Because those are both zeros, this is really convenient. So I'm just going to put row 2 and multiply it by -1 here. So that's 0, 0, +1, 0, +3. And now again, think about what you're actually trying to accomplish here in the second step. It's get a 1 in front of one of these numbers and then get rid of those 2 numbers. So I'm trying to get rid of this. So I'm going to do that now since I already had the 1 in front. I'm going to multiply by 13. Remember, this is technically row 3 up here. So it's 13 times row 3 plus row 4. Gives me 0. 13, -13 gives me 0. And now you may want to pull a calculator out because some of these numbers are going to be a little large. And shouldn't happen to you on a test. If it does, then you're going to have to multiply it out by hand. But this shouldn't happen to you unless you do something weird. Or, unfortunately, make a little mistake. So -5 times +13. And then subtract 13. So it looks like I have -78 here. Multiplying by 13, so that's going to give me -26. Subtract 23. or negative 49. Multiplying by positive 13, so I get negative 208, subtract 75 to get negative 283. And I'm guessing at this point you're probably scared because something's wrong, but keep going. Sometimes the numbers do get messy, and sometimes you have fractions in there and that really gets messy. But keep going until you get to figure out what that z is. Once you find out what z is, like I said, check in the back of the book. Obviously you can't do this on the test, but check in the back of the book to see, do I actually have the right number? If I do, then I have nothing to worry about. I'm obviously there. If I don't, then I got a little mistake in there, and I'll see if I can find it. Alright, so what do I have to do to get rid of this? Because remember, I already got the 1 here. Get rid of that. Well, I'm going to have to multiply by 78. So multiply row 3 by 78, add it to row 4. And that's going to give me the 0 that I want, the 0 that I want, 78, negative 78, the 0 that I want. Doesn't matter what I multiply that by, it's negative 49. And now 78 times 3 minus 283, and it looks like I get negative 49. And look how convenient that is. Obviously that goes into that very nicely, so this is where I would say, okay, I'm going to actually divide that by negative 49 to save myself from writing this entire thing out again. And that means that this is really 1, 1. Alright, so now I've got the Gaussian part done. Now we're going to do the Jordan part. I'm going to use that 1 to get rid of these 3 numbers. So, write down another matrix. This time working backwards, it's the bottom row. That's not going to change anymore. Bottom row is completely done. I would check your answer to make sure that W is actually equal to 1. If it's not, then you know something's wrong. You got to go back and fix it. Alright, so don't have to do anything with that one, so just copy down that third row. That's actually completely done because I've got 0, 0, 1, 0. Need to get rid of that negative 2, so I'm going to multiply this by positive 2. So positive 2 times row 4 plus the second row. And doesn't matter what I multiply, it's going to be 0 plus 0, so 0. 0 plus 1, so 1. 0 plus negative 5, so negative 5. Again, it's the reason that those need to be 0 so that those things don't change, because I don't want them to change right now. And then it would be 2, negative 2, or 0. 2, negative 16, so negative 14. And now think, how do I get rid of that 4? I'd have to multiply by negative 4. So negative 4 times row 4 plus row 1. Again, because of the 3 zeros, those first 3 numbers won't change, and I don't want them to right now. So 1, 2, and 2. Negative 4, 4 will give me 0. Negative 4, 11 will give me 7. So now I've used this one to get rid of those numbers. Shift, now use this one to get rid of those 2 numbers. So again, write out another matrix. Bottom 2 rows now are completely done. So you can just continue to copy those down. 0, 0, 1, 0, 3. And now I'm trying to get rid of that negative 5, so I'd have to multiply this by positive 5. So positive 5 times row 3 plus row 2. And again, because of those 2 zeros, those 2 numbers won't change. It's still going to be 0, 1. 5 and negative 5 would be 0. 0 and 0 will give me 0. That's why I want these to be zeros too. I don't want those numbers changing at all. And then 15 and negative 14 should give me 1. Going to multiply this time by negative 2 to get rid of that 2. So negative 2 times row 3 plus row 1. And again, because of these 3 zeros, those 3 numbers don't change. So the 1, the 2, the 0, that's not going to change. Negative 2 plus 2, it's going to give me 0, of course. And if I multiply this by negative 2, it gives me negative 6 plus 7, or 1. So using that one, I got rid of those 2. The last step I've got left, take that one and get rid of that 2. And so I'm just going to draw a little arrow over here. And so the bottom 3 rows now are completely done. And so I'll quick write those down. And now think, what do I do to get rid of this 2? I'd have to multiply that by negative 2. So it's negative 2 row 2 plus row 1. And again, these 3 zeros will not change those 3 numbers. And of course, I don't want them to change. That needs to stay a 1. Those need to stay zeros. Negative 2 plus 2 gives me 0. Negative 2 plus 1 will give me negative 1. And the nice thing about the Gauss-Jordan elimination is once these things are all zeros and that's your main diagonal, there are your answers. So it's X, Y, Z, W. So again, it adds, if you had a 4x4, it adds 3 extra steps. If it was a 3x3, it would add 2 extra steps. But idea-wise, it's the same thing. It's just a few more steps. Hopefully that'll help you out with your homework. If not, feel free to come in and ask for help.